Can you hear me? Or can you hear me? Can you hear me? How is audio right now? Please confirm. Can somebody confirm if you can hear this? Can somebody confirm if you can hear my voice? Okay, that's great. Okay, can you confirm audio and screen? Okay, that's good. We'll get started now. Right. Right. So let's look at my virtual machine. If you look at the virtual machine, please start your quarters prime. So in the quarters prime, we are going to open the project. Okay. File, open project, and it is design 0. Now remember, last class we archived the project. So that's why we have this file here. So if you do that, it's going to unarchive the file. So do not select this. You always select this file, which is a QPF. QPF is a file you should select. So when you select the QPF, you can open. It's going to restore the project. So this is a project. We proved the source code worked from Monday. Okay. So now we're going to go to the next step. All right. So is my audio lagging or it is not? Okay, great. So this circuit has two inputs, three outputs. Okay. Before we start the new project, I'd like to go over the assignments first. Okay. If you go to ULearn, this is the assignments for D1. D0 has no credit. D1, you can do it. You have to do it for credit. Okay. So what you are going to implement is this truth table here. If you can see, this is a truth table given to you in descriptions. Press, non-press, for key 0 and key 1, in LED R3210 with different behavior. Okay? So your job is to do the following. First, you need to translate this truth table into binary like this. So this is a truth table for D0. You are going to do the similar thing. You need to convert the description into ones and zeros. Okay? So in this case, the operation is not going to be OR and XOR. Okay? It's going to be some logic. Okay? So once you convert everything into ones and zeros, you are going to create a code in VHDL that will implement the logic. Okay? And that's your design one assignment. So your job is to create the truth table with ones and zeros. Then you need to write a code to implement the truth table. When you finish everything, you need to submit your archive project, which is the archive QAR from quarters, the truth table, and then a video of a fully working project. Okay, not VGA, but fully working program. Okay, make sure that in the video you put yourself in there too. The format of the video is 720p MP4 only. Many of you took the class with me last term. You have done this many times already, so there's no news to you. Okay. So on ULearn, there are two separate areas to upload your source and your video separately. So for demonstrations, make sure that you upload it to the demo part or the demo upload. For source code and truth table, please upload to source code and truth table. Okay? All right. Any question? Please ask now. Hold on. Somebody, hold on. Hold on 1 second. Okay. Yes, each assignment has its own area for uploading the code, the demo. Okay, so if you go to Euler, you should see D1 source and D1 demo. Okay, are we good? Remember, we do not upload individual files. We upload the archive. So I showed it to you last class how to archive the project. It will include everything I need because in the project there are many, many files. You only need to upload the archive. Are we good? Um, I see. I see Manny, Christian, Kerben, Ibrahim, Vant, Muhammad Alghamdi, Muhammad Khaldi, Ibrahim. Is Muhammad Haji here? Is Muhammad Haji here? Muhammad Haji here? Okay, what about Aaron? Is Aaron here? Okay, I can see Muhammad Haji. All right. So now we can move on to the next project. Okay, so we're going to use D0 as the starting point for the next for today's lecture. Okay. All right. So make sure that you have the project open. Okay. So before do anything, what we're going to do is we're going to recompile the project. So processing, start compilation, and let it go through the process. So now your project compiled, right? Now if you look at the progress, you see this last one. Yes, you can have warnings. That's okay. You see the last one. The last one will not execute by default. Okay. The last one is needed if you need to run simulations. Okay. So you need to do this manually. To run simulations, you need to make sure that this is in green. To do that, very simple. Double click the arrow, and then it's going to go through the process and then finish it with two warnings. Okay. If your project does not compile, you cannot execute this part. Okay, this part is only available if your project compiled okay. No errors. You can have warnings, but no errors. Okay. All right, so make sure that everybody can finish everything, all the tasks on the left. Okay, so complete is 1, 2, 3, 4, 5. 5 of them. Okay. Or if you don't see this window, it's because you close it. So view, utility window, task. Then you can turn it back on. Okay. So please let me know if you have finished all the tasks, including the EDA netlist writer. Yes, this step's supposed to be pretty fast. It takes about probably a few seconds to do. So we have Manny done, Corbin done. Anybody else? Is Douglas here today? Douglas? No? Okay. Okay, so I assume everybody is. Oh, okay, Aaron's still working on it. Okay, great. So let's move on. Now, this is a circuit that you built using VHDL. One thing to verify your circuits is to put the circuits on the board and then try it. However, sometimes you cannot do it that way because maybe you don't have the board, or you want to verify it to get confidence before trying the board. The process is very simple, is to simulate your circuits. Okay? And you have done simulations in other classes, but for this class, we're going to use a new tool. The new tool is called Modelsim to run simulations. So before you start any simulation, you make sure that everything here is green. Okay. Then you go to Tools, Run Simulation Tools, Gate Level Simulations. Okay, so Tools, Run Simulation Tool, Gate Level Simulations. And then click, and then wait. They ask you, hey, what kind of language are you using? We're using VHDL. Okay, you click OK. Apparently, I didn't run that properly. So let's double click, rerun it. Tools, run simulation tools, gate level simulations. Okay, now it's working. When everything works, you are going to see a new screen pop up. Okay, so now if you see it, it's on the bottom of your virtual machine. It looks like this. So let's maximize this, right? And this software has many windows, right? Many windows. And this is your library, object, processes, and terminal. This software is command line driven, so you know the commands. Okay? So today we're going to go over some basic commands. All right. So is everybody ready? Yeah. If they tell you, hey, you don't have the netlist ready, no problem. You just rerun the netlist writer, and then you will be fine. No, no problem. You can recompile your projects if they all turn yellow. That's okay. So Manny, are you all ready? Okay. Yes. um, when you compile a project, you will go through one, two, three, four steps. If you want to run a simulation, you do the last step manually. Okay. All right. So let's going back to this. So here you see a bunch of libraries. Okay. Now, how do you start a simulation? To start a simulation, the first thing you need to do is you need to pick the entity you want to simulate. Okay? Now, if you look at the library window, there are many entities in this project, not the project, in this software. The one that you need to look at is design zero. If you look at here, this is design zero. Okay, so if you click on work or get gate work, you can see that design zero it's under gate work. See that? Okay. So what you need to do right now, you need to simulate, start simulation. Okay? And from gate work, you select design zero. Now you do not type in anything. You have to select using your mouse. Okay. Design zero, resolution it's 1 nanosecond resolution. And we're using VHDL, so there's nothing else you need to configure. Okay. Everything is default. So going back to this page, it's gate work, which is here, design zero, nanosecond resolution. Okay, and then you click on OK, and then you can see that things will start responding to your click. All right. So if everything works, you should see the window changed, and you can see this thing got populated. See that? It was blank. Simulate, start simulation, and then gate work, design 0, nanoseconds, okay. All right. Let's continue. In this object window, it has everything you have in the project, plus internal stuff to the quarters prime. Okay. Now, what you care is the input and output because you put them in. The grounds, the VCC, you didn't put it in. It was put in there for you by quarters. Okay. So what you need to do is you need to ignore those ones that you didn't put in. So if you look at this, we put in the key 0 as our input, key 1 as our input, LED 0, LED 1, LED 2 as our output. Okay, so these are the 5 objects you care. Everything else, you don't need to concern with that. Okay, all right. So far, so good. So now, how do you see the waveform? The first thing to do is you need to create a waveform. Okay? To do that, you need to type in commands. So follow my window and then follow my window and type in the commands. Okay. So the commands you need to type in here. So the command is add space wave space dash color space curly bracket blue, case sensitive, close brackets, item color blue, format binary, and sim forward slash colon forward slash design 0 forward slash key 0. You type it in the transcript window, which is here. This is the transcript window. Okay. Yeah, the screen capture. Hold on, let me see if I can move this up. One moment. Hold on, let me see. Let me dock it in different locations. All right, now you should see it. I put it on the top. By default, it is on the bottom. Okay. So this is the command you need to type in. You see the command now? Can you see the command now? Okay, that's great. Type it in. Remember, case sensitive. Are we good? Okay, it's not sim, it's sim. SIM. Short for simulation. Are we good? Okay, that's great. So once you type it in, finish with a semicolon, and then hit enter. And then the screen will turn into this. Okay? Okay, so now if you pay attention to this window, this is your waveform window. So what we just did, we just added my input using color blue into the waveform window. Okay? Remember, blue, you have an open bracket, open curly brackets, and close curly brackets. Okay? It is not a regular bracket, it's the curly bracket. We don't use brackets, we use curly bracket. Yeah. The fonts in this software is very small. There's nothing you can do about it. The only solution to you is to get a bigger TV. You can see the fonts. Okay? So we just added, yeah, you use curly brackets, not parentheses. Okay? And you can copy and paste the command for a different input. So in this case, I'm going to add key 1 to my waveform. So you can see that key 0 and key 1, they both showed up. Okay? Now the commands will put the objects on the waveform based on the order of your entry. So if you add 0 first, you'll show 0 first. If you add 1 first, you'll show 1. Okay? So you need to think about how you want to arrange these inputs. Okay? All right. So far, so good, everybody? If you have a command that you want to make changes, you can use the arrow keys to change the command. It's a terminal. You can also copy and paste. That's what I did. Yes, at the end of each command, you type in semicolon. That's just like you type it in the VHDL. Semicolon, finish the line, and then you hit enter. Okay, Doc, what kind of error message do you get? So I assume everything is fine now. Well, the space matters within the parentheses, not parentheses, the brackets. But between each argument, you must have a space. Now look at the command. So I'm going to do is I'm going to copy and paste the command into my notepad. You can see it better probably. So that's the command. You have a space. It's a space here. Okay. All right. It's okay if you're behind. This doesn't matter because the videos will be on the channel after the class, probably next day. I do not control the video thing. It's controlled by YouTube. Okay, so I'll post the video tomorrow. All right. So let's go back to the model sim. So now we have put inputs key 0 and key 1 here using blue. Okay. Now we're going to use a different color for the outputs. Okay. All right. So in general, when we do the inputs, we use blue. Okay. And for outputs, we try to use green. So for outputs, LED0. So we're going to use green. Okay. So for outputs, I'm going to just type in this command. So for those who cannot see this clearly, please look at my my notepad, I change the color to green for the output. Okay, all right. You do the same thing for LED one. I'm sorry, LED one. If you make a mistake, you can easily move them up and down to arrange them using your mouse. Okay. So now on my screen, you can see that I have key 0, key 1, LED 0, LED 1, and 2. So these are the two commands for inputs and outputs. So we use different colors. Yeah. Again, if you're behind, there's no problem because you can rewatch the video. It has all the commands and recordings. You can type it in. It's not very difficult. We're still in the beginning of the class. Okay, so looking at the commands, please let me know if you can add the inputs and outputs to the screen. Okay, not the screen, to the waveform. You do it for LED 0, 1, and 2, all of them. You want to do all the inputs and all the outputs on the screen. Okay? But the syntax is very similar. Remember, all inputs we use one color, all outputs we use a different color. We don't mix the colors. So my options is always blue for input and green for output. That's right. You need to type in the letters right. It's green color. Okay. So far we have Rawa done, Manny done. Anybody else? Okay, Douglas done. Muhammad Khalid done. Yeah, Corbin done. Yes, if you add something by accident or have duplicates, you can select the line and delete it. Just you go to the waveform window and then select it. I think it becomes white, and then you just hit delete key and then it will disappear. Uh, it's okay if you're behind, no big deal. You can still watch the video afterward. Okay? For now, our design has only 2 inputs and 3 outputs. It's manageable. But for future work, you have many more inputs and many more outputs. You have to watch, view many waveforms at the same time. But anyway, so everybody knows how to do that now. The syntax is fairly simple. Okay. All right. So let's see what we have on the screen. You can see that the name is design 0, key 0. That means your entity is design 0, input is key 0. Design 0 entity is design 0, input is key 1, and then the same thing for outputs. Okay, so right now you can see that there's no value associated with these. So what you need to do now is you need to give the input values such that your circuits will respond to inputs and then give you the output. Okay, so there's a different command. All right, so how can you give values for inputs is to provide values at different time in space. Okay, so what I'm trying to say is you say, okay, I'm going to change my inputs from 0 to 1 at a certain space, a certain time, or 1 to 0 at a certain time. Okay, you need to provide the values. So the syntax is, oh, let me show you the syntax. Uh, so this is syntax. So this to add values to inputs, the command is force deposit your input and then put down the values at different time. So this means this is binary 0, binary 1, binary 0. So it's a 0, 1, 0, sorry, 0, 0, 1, 0. At time 0, it's 0. 1 microseconds is equal to 1. 2 microseconds is equal to 0. So this is 0, 1, 0. Okay? If you want more values, you can just keep adding values after this. There's no real limit how many values you can put in. Okay, so for now, let's just start with 3 values. Okay? So to do that, is going to force values on key 0. Okay, so that's the syntax. So why do we use 1 microsecond? If you don't know the speed of your inputs, you can always use 1 microsecond. It's a good speed. Okay? If you know the speed of your input, for example, if you know the speed of input is 100 nanoseconds, then you should use the real speed instead of some, default speed. Default, you always use 1 microsecond. If you know the speed, change it. Okay? So please copy this. And then we're going to use different values for key number 1. All right, so we're back online. Yeah, I think what happened was that the internet connection got disrupted. That's why it was also buffering on my side. Okay, is the voice okay? Okay, so voice is fine, screen is fine. Let's continue. All right, so this is the command for key 0. Let's do one for key 1. Let's use different values. So for key 1, Let's use 0, 0, and 1, and 1. Okay, so that's a new command. All right. Okay, so I just put in the new value for key 1. Let me know if you finish typing the commands so we can move on to the next step. Okay, let's move on. I think everybody is done. Okay. Um, Look at the syntax. Microseconds. Microseconds. If you type in uppercase U, or it's not going to take it. Okay? Yeah, it is not 0 second. It's 0 second. Yeah, it's 0 seconds, not 0 seconds. It's not 0 nanoseconds. It's 0 nanoseconds. Okay, so let's move on. All right. So we added the input and outputs on this waveform. Then we force the values for inputs. Now it's time we can run simulations. So going back to the terminal. To run simulations, you need to specify how long you want the simulation to run. Okay. So the syntax is to specify the runtime. So for example, you do run, looking at your input, you have 0, 1 microseconds, 2 microseconds. Okay. Remember, the input changes at 1 microsecond. So if you only run to 2 microseconds, you only see 0 and 1. You need to run longer than 2 microseconds. And our input changes 1 microsecond interval. So what we'll do is we'll type in run 3 microseconds. Okay, so that's the command. Run 3 microseconds. And hit enter, and then something will happen. Okay, and then I'll tell you how to view the waveform. So to view the waveform, you go to your waveform window. Okay, then you go to view. Uh, Zoom. Where do you see anybody see the zoom? Where's the zoom? Okay. Where's the zoom? Oh, okay, okay. I found it. I found it. It's in the. It's not in the menu. It is in the toolbar. Zoom full, and then you can see the waveform here. Okay. Click on this button here. You can see the waveform. All right. So what I'm seeing here is if input equal to 0, 0, output equal to 0, 0, 0. If input equals to 0, 1, output equals to 1, 0, 1. Input equals to 1, 0, output equals to 1, 0, 1. Okay? All right, so this is the behavior of your circuits with 3 different inputs. It's not the screen quality, is that when you stream, it doesn't really stream. Like you need to when you look at the YouTube live, especially for this kind of programs, you cannot make your windows small. You have to use your Windows big screen, like full screen, then you can see the quality. Okay? When you stream, the recording is done in HD. But if you shrink your windows very little, then you don't see the HD. You have to make them the screen big. Okay? Okay. Are we good? No, you have to click on this button here. Okay? When you click on this button, it's going to show you the waveforms. However, if your circuit was not built correctly, then the output values will be different. Make sure that your blue waveform looks like mine. Okay, are we all good? Okay, are we good? All right, so going back to the waveform window, if you look at the waveform window, you can see that the time scale in the bottom, it is at 3,000 nanoseconds, which is 3 microseconds. So this is where the simulation stops. Okay, so from 0 to 3,000 nanoseconds or 3 microseconds. If you want to run longer, you need to run additional time. You need to type in a command again. Then it is going to run another 3 microseconds on top of whatever you have finished in the previous uh, simulation. So right now you can see the time changes to 6, but you can see the values won't change. The reason is you only specify the values up to 3 microseconds. If you want to run longer, you have to change the values beyond 3 microseconds. Understand? So what we need to do is, before you run any simulation, you need to plan ahead. Okay, how long do you want the simulation for? Okay, you don't need to run it for very, very long. You want to exercise all your inputs combinations. So for example, right now, if you look at these, I only exercised 00, 01, 10 combinations. There's one combination is missing, which is the 1-1 combination. Okay? Now to do that, you need to restart the simulation. Now when you restart the simulation, you do not have to exit the tool. You don't have to change anything. You can tell the tool right now, I want to clean or wipe out previous simulation results, and I want to start from 0 again. To do that, you type in this command, restart -f. Okay? When you do that, it's going to wipe out the previous simulations. Sorry, wrong. It's restart, not restart. Restart F. Okay? Restart -f is going to restart the simulation. So when you type that in, you can see that all your waveform values disappear. Why? Because you just wipe out the inputs, and at the same time you wipe out the outputs. Okay? All right. So this is like the beginning of your simulation. The only thing the restart doesn't do is to wipe out your waveform input and output. So these will stay on the screen. Okay? So now, if you look at the commands, we have exercise 00, 01, 10. We need one more combination, which is the 1-1 combination. Okay. So we're going to copy, paste this, copy, and paste this, and run it for 4 combinations. 1 microseconds each combination. It's going to be 4 microseconds. And then if you look at it, you can see 4 different combinations now. This is your cursor, you can move it. So 0, 0, 0, 0, 1, 1, 0, 1, 1 combination. And they can see the response for the output. Okay, so this is driven by your circuits. All right. So make sure that you can do this on your own. because you'll be doing these a lot on your own for the assignments. So these are the commands. Okay, the VM is frozen, but I have the same before you add one. It doesn't matter. What you need just a command. These are the values for your simulation only. Yeah, once your VM is working again, you can type this in again. No big deal. What you want to make sure that you understand the command. Okay, the syntax for the commands. What about the others? Can you run the simulation with 4 different input values? These are 3. Are we all good? Okay, Aaron is good. Okay, yeah, you can always go back to see the video. No big deal. All right, so Manny, what's the problem? Okay, if you are not getting the same waveform for the outputs, that means the circuits that you built in quarters prime for the VHDL is not correct. When you type in these commands, they only exercise the inputs. Then your circuits exercise the output. Okay. So right now, if you look at these commands here, okay, these commands should give you the blue behavior. Then the circuits will give you the green behavior. If your green behavior is different from mine, it means this is wrong. Understand? You need to check here. Okay. All right. So two more things, then we are going to probably finish today. Okay. Now this is a waveform of the circuits, and this is a waveform of the circuits. Okay, so Manny said the blue doesn't match yours. Well, so the only reason your blue does not match mine is because you type in the wrong commands. Look at the command here, key 0 and then key 1. Okay, and then on the screen is key 0 and key 1. Yeah. Well, if your blue doesn't match, your input does not match, the output will not match. Okay? Right now, you should look at make sure that your input match my inputs. The blue should look identical because you use these commands to change the values. If you use a different commands with different values, of course, it's not going to be the same. Okay? The key here is to make sure that you're using the same command. If you're using a different command for input values, then the output will never match, even though it's the same circuit. Right. Everybody else, are we all good? Besides Benny? Okay. Yeah. So if you find out the reason, fix it. We'll look at it again. Okay. All right. So let's continue. The next thing is how do you save this waveform? Okay, because in the future assignments, I need to see to make sure that your circuit works. You need to simulate the circuits, and then you need to save the waveforms. Okay. Uh, So you click on waveform window. Okay. This is the wave window. You go to File. Okay. Export image. So let's put it in the project, which is ENGN3035 design 0. So this is design 0.bmp. Okay, now I always use .bmp because it's universal, everybody can read it. Okay, there's no really special software you need for this BMP file. Save. And then it's going to save whatever you have here onto the file. Okay, so let's go to virtual machine, to the project folder, design 0, there should be a BMP, which is this one. Now file size is like a 1 megabytes. So if you double click, you should see the waveform. So this is a way to document your work, and this is also something you will submit for future assignments. Okay? Any question about the process to export the waveform into an image? Any question about the process to export image? Okay, what's the question about the name? Yes, you're supposed to type in design 0 because this belongs to design 0. If you have a different assignment, design 1, then it's going to be a different name. You cannot import image. You can only export image. Go to File menu, File, Export Image. Then type in the name of the image file. Then it's going to export it for you. So I don't understand the question. What do you mean by QPF and QSF? You're not using anything. You are creating an image file, .bmp. Yeah, you click on the waveform, File, Export Image, and then that's the file. That's it. BMP, save, and that's how to do it. The file type is BMP. That's correct. All right, so now we finish everything for the Modelsim. We can exit the tool. To do that, you need to simulate end simulation. They ask you, do you want to quit? Yes. Then you lose all the object window, all the waveforms. Okay. Then you go to File, Quit to get out from Modelsim. Okay. Then you're back to quarters prime. Now, one thing you need to know that when you simulate, all of these has to be green. If you make changes to your source code, you always have to recompile the file. Once you recompile the file, you need to restart a new simulation. Okay? Because the simulation always work on the last saved project. If you make changes while your model sim is open, it cannot redo the simulation for you for the new designs. So every time you make changes, get out from model sim first, make all the changes you need to make, recompile the project, and restart model sim. Understand? Understand? Yes? No? All right. If you look at our original schedule, today is a due day for D1. Obviously, you cannot finish it. So I'm extending D1 to next Thursday. So next Thursday, you need to finish D1. Okay? And we'll talk about D2 when we'll come back on Tuesday. Now, today's live, one improvement is the voice. So I think the lagging is much reduced, right? If you check on ULearn, D1 is due next week. So you have until next week before class starts to submit everything. Remember, source and demo are separate areas. You submit submit the files and videos. Okay, that's right. Today there's no lag or much less lag in the voice. Okay? No problem. You'll figure out. We're still in the beginning of the term. Not much have changed. The design very simple. There's only a few lines. I mean, look at the design. There's only 30 lines of code. How can you get wrong? Right? Now, before we finish today, any questions? No, the right now, we I require you to take videos of your working design for the demo. The waveform is going to be the source, okay? Because everything is the software. The demo is the video. Video is always the demo, or demo is always video. Understand? The waveform is always a source. Okay, any more questions? No problem. I will post the code on ULAR, and then you can try it, my code, to make sure that it is different. Okay. If you see that doesn't work, we can look at it next time, next class. You can send me your code. Okay. Anybody else question? Okay. If you don't have any questions, you can exit the live. I'll get ready for the next one. So next live is going to be at what, 3:50? Okay. Yeah. So Manny, send me your code. I can take a look at it because the code is so simple. There's only 3 lines that matters. So you can exit the live, and then I will terminate it. Yeah, D1 is due next week. Yes, you need to submit the waveform in the video. I'm going to terminate the live in 1 minute. Okay? Well, D0, you know how to submit it. It was just a test area to make sure that you can see it. Okay? D0, there's no credit associated with D0. Okay? I'm going to terminate the live now.